Alright guys, so back into properties of exponents here, and this one will deal with negative exponents. So some things we want to be able to do is understand and apply properties of integer exponents, which we started in the last section, where when we multiply things with the same base, right, we would add exponents. And when we, let's see, why don't we do that real quick, like when we do something like, remember the rule x to the a times x to the b equaled x to the a plus b. And then when we divide exponents, as long as the base was the same, something to the a power divided by something to the, oops, I meant to write a b there, power, that was when we would subtract exponents. Okay, so there's several examples in the last section, the last video we did. Let's kind of dig into that a little bit more, and let's see what happens and how to simplify expressions with negative exponents. Okay, so here's a completed example. Let's say we have this expression here, 4 to the third over 4 to the 8th. Okay, and the rule for that, again, when you're dividing things to a power, as long as they have the same base, which they do, they're both 4 to a power, we can subtract the exponent, so you can see they're doing that down here. And 3 minus 8, of course, is negative 5. Okay, now the connection, okay, and it might seem weird, right? We have a negative exponent, but the connection here, when we have a 4 to the third over 4 to the 8th, when we write it out in expanded form, right, 4 to the third, you see the numerator, 4 times 4 times 4, and then the denominator has 8 factors of 4. Like we did on the other video, when you start reducing, right, like a 4 divided by 4 cancels out, that's why all three up top cancel 3 of them out at the bottom there. We're left with, there's still a factor of 1 in the numerator. It's not just gone, but then the denominator, as you can see, has 5 multiples of 4, or 5 factors, so it's 4 to the 5th power. Okay, so the thing is, these two expressions are equal to each other, right? 4 to the negative 5th is the same as 1 over 4 to the 5th power. Okay, and that's just a brief example taking a look at what a negative exponent really simplifies to. And basically, the idea here is if you have something to a negative power, it can be written as the reciprocal. Okay, reciprocal is a fancy word for like flipping a fraction. Okay, or if there's no denominator, it means just putting a 1 over it. So 4 to the negative 5th is going to be the same as 1 over 4 to the positive 5th. Okay, so let's keep doing, let's run through another example. The whole negative exponent thing is kind of weird to picture at first, but let's see what we can do with it. So consider this expression. We have x to the third over x to the 5th. Let's rewrite it in expanded form. Okay, so we're taking x to the third over x to the 5th. So in expanded form, the numerator would be x times x times x. And the denominator, there would be 5 of them, right? 1, 2, 3, 4, 5. And then the concept is that since x divided by x cancels out to be 1, this x divided by x cancels out, this x divided by x cancels out to be 1, what this thing really equals is, clearly on the bottom there's 2 factors of x remaining, and it's not just 0 in the numerator, because again, it could be multiplied by 1, so we need to keep that 1 factor in the numerator, so this really equals 1 over x to the 2nd power. Okay, now if we do the same exact problem by subtracting exponents, taking x to the third over x to the 5th, remember the rule from the previous section was that equals x to the, you subtract exponents, and 3 minus 5 is actually negative 2. Okay, so the results that we got up here, 1 over x squared, and over here, these things are equal to each other. We did the same problems in part A and B, we just did them using different methods. Okay, so that's one more example where you can see whenever you have that negative exponent, it's going to end up becoming the reciprocal and make the exponent positive. Okay, so let's keep looking at that a little more. Okay, so back that term called reciprocal, you can see the definition over here. It's just basically the multiplicative inverse, so it's kind of a fancy word. But for example, the number 6, its reciprocal would be 1/6. Okay, because again, you can think of the 6 as having, if it's a whole number, it can have a 1 underneath. So the reciprocal is just flip the fraction, it's 1/6. And the reason it's called a multiplicative inverse is because that these two numbers, when you multiply them together, equal 1. Okay, like so for like another example, 2/3, it would have to be multiplied by the reciprocal, which is 3/2, right? Just flipping the fraction again to make it equal 1. Okay, so let's dig into this a little bit. Let's see what's going on. Can we simplify x to the 4th over x to the 2nd? Okay, and let's do it two different ways. Let's do the where we expand it out, because this is always an option. If you forget the rules about subtracting exponents, you can always expand it out and then see what happens. Right, x to the 4th on top, x squared on the bottom. Right, x divided by x cancels, x divided by x cancels. This one is just left as x squared in the numerator, so we can just write it as x squared. We don't have to put over 1 in the denominator if you don't want to. Usually we don't. Okay, the other problem though, x squared is the numerator, and x to the 4th is the denominator. Okay, so again, we can still cancel some things out. X divided by x cancels out to be 1. X divided by x cancels out to be 1. So in this case, the x squareds are in the denominator, and remember there is a factor of 1 in the numerator. It's not 0. So we end up with 1 over x squared. And so by looking at these two things, right, x squared and 1 over x squared, these are reciprocals of each other. Okay, and that's because, look what we started with, the original expressions, those are reciprocals of each other. Okay, so the answers are reciprocals of each other. Okay, again, reciprocal, you just flip the fraction. If it's not a fraction, put a 1 under it, then flip it. That's how you get the reciprocal. Okay, so let's do a couple more examples here. Can we simplify 2 to the 9th over 2 to the 5th? Okay, so let's do this one. And let's do the shortcut way. Let's do, we don't have to expand it if we know the rule. The rule is that we can subtract the exponent. So 2 to the 9th over 2 to the 5th is going to equal 2 to the 9 minus 5 power, which is 2 to the 4th power. Okay, this problem, 2 to the 5th over 2 to the 9th, is 2 to the 5 minus 9, right? That order is important. It's 5 minus 9. And that one, 5 minus 9, is actually negative 4. Okay, so again, these answers are reciprocals of each other again. All right, let's take a look at example B here. Can we write 6 to the negative 2 as an equivalent expression without a negative exponent? Okay, sometimes, actually most of the time, negative exponents are not considered a simplified form of an answer. Okay, so kind of like when we deal with fractions, you generally want to reduce those down to simplify them. It's the same idea as if you have something written with a negative exponent, you generally want to rewrite it. Okay, so the trick to rewriting it again, since the exponent's negative, you automatically think reciprocal. Okay, so that's why it ends up with the 1 over 6 squared. So let's do a couple examples on the bottom here. So a to the negative 4th, right? And again, if it's not a fraction already, just put a 1 under it. Since the exponent's negative, we need to do a reciprocal, and then we can make the exponent positive. Okay, so again, as soon as you see a negative exponent, right, I'm looking right at this problem, I'm saying, oh boy, there's a negative exponent right there. I'm automatically thinking reciprocal, and then you make the exponent positive. Okay, what about 8 to the negative 3rd? Again, it's not a fraction yet. It might help. Let's put a 1 under it. It does have a negative exponent, so let's do a reciprocal, then make the exponent positive. Okay, part C, take a look. Is the exponent negative? Yep. Okay, so automatically thinking reciprocal. So instead of being 1 over 3 to the negative 2nd, I'm going to put the 3 and make the exponent positive and make that be the numerator. Okay, just put the 1 under there just to be safe, even though we don't need to. Okay, and that one can actually be simplified. 3 squared is 9. Okay, and we could have simplified this one too if we knew what 8 to the 3rd power was. But you probably just need a calculator to do that. So just leaving it as 1 over 8 to the 3rd would be acceptable as well. Okay, but that's the deal. If you see a negative exponent, you're going to automatically do a reciprocal, and then you can make the exponent positive. All right, let's simplify a few more things here. Example C, they do an example for us where they simplify r to the 8th over r to the 15th. And again, our answer should not contain any negative exponents. Okay, we want to be considered simplified. So if we have a negative exponent, we're going to do the reciprocal trick and take care of it. So first off, step 1 is to divide. by subtracting exponents, right? Okay, again, it's something to a power over something to a power. Since the bases are equal, they're both r, right? We can subtract exponents, so we would get r to the 8 minus 15, which is equal to r to the negative 7th power. But again, negative 7 as an exponent is not simplified, so we're just going to do a reciprocal. You can think of it as having a 1 underneath it, so its reciprocal makes it 1 over r to the positive 7th. Okay, so let's do a couple examples down here and try these, see. So y to the 4th over y to the 8th. So I'm able to subtract exponents, right? 4 minus 8, so y to the negative 4th. Okay, I don't want to leave the negative exponent, so I'm going to do 1 over, and that will allow me to rewrite the exponent as positive in the denominator. So we're going to have 1 over y to the 4th. Okay, 10 to the 12th over 10 to the 15th. Again, we can subtract exponents. It's 10 to the negative 3rd. Okay, we don't want to leave a negative exponent, so we're going reciprocal. 1 over 10 to the positive 3rd. Okay, another option, since we know 10 to the 3rd is 10 times 10 times 10. Okay, we could also write this as 1 over 1,000. All right. Now, part C is a little bit messier, right? There's more than one term in each part. So let's think about this. Is really 4 to the negative 2nd times 5 to the 7th over 4 to the 3rd times 5 to the negative 2nd, right? So I'm just going to put the dots in there just to kind of separate these. And then let's think about the ones that are negative right now are those two. Okay, so one trick, what you can do, we could make all the exponents positive first. Okay, so if we did that, the ones that have a negative exponent right now need to become their reciprocal. And what ends up happening in a fraction, as you've noticed, if something's in the numerator, its reciprocal will move it to the denominator. Okay, and if something is in the denominator as negative, same thing, it'll end up moving to the numerator. So why don't we do that first? Let's think about what we have. So this 4 to the negative 2nd is actually going to become 4 to the 2nd down there. Okay, so I took care of that one. The 5 to the 7th up here was fine because it was already a positive exponent, so I kind of took care of that one. The 4 to the 3rd is good because its exponent is already positive. And then this last term here, its exponent was negative, so it's going to move up to the numerator and become positive. That's what its reciprocal means. It means it's going to move up now to the numerator. Okay, now all we got to do is finish simplifying. The numerator is a problem like we saw in the previous section. Okay, it's 5 to the 2nd times, 5 to the 7th times 5 to the 2nd. That's when we add exponents, remember? So the 7 plus 2 is going to make this 5 to the 9th. And in the denominator, 4 to the 2nd times 4 to the 3rd, we're going to add exponents again. It's 4 to the 5th. Okay, we are not multiplying exponents, we add the exponents, like we talked about the other day. Okay, let's just do a couple more quick ones. Checking our understanding here. X to the negative 7th again, right? Negative exponent automatically means reciprocal, so we're going to do 1 over, and then the exponent will become positive. Okay, so 1 over x to the 7th. Okay, 5 to the 6th over 5 to the 9th is going to end up equaling, if we subtract exponents, 6 minus 9 is negative 3. Okay, and again, we don't want to leave the exponent negative, so we're going to do 1 over and then make the exponent positive. Okay, and number 8 is one of the more complicated ones because it has 2 negative exponents. So each of those terms, when the exponent's negative, we need to do reciprocals. So let's just walk through and see where things are going to end up. One term at a time. The x to the 5th was good because its exponent was positive. Y to the negative 2nd is going to end up going to the denominator, right, and make the exponent positive. That's because its exponent was negative, so reciprocal will mean it goes to the bottom. Okay, this x to the negative 4th, its exponent's negative, right, so it needs to move, it needs to go to the top and become positive. That's like doing the reciprocal. And then y to the 4th was good where it was because it was a positive exponent. So all I did was move the negative exponent terms. Okay, that and that, those are the ones we did reciprocals for. Okay, and then our final step is cleaning this up. The numerator, x to the 5th times x to the 4th, we add those exponents, we get x to the 9th. And then y to the 2nd, y to the 4th, add those exponents, we get y to the 6th. So that would be our final answer. Okay, and notice we have no negative exponents in any of our answers. That's how you simplify these things.